Hello everyone, so we're going to do example 7 from our notes. This is a related rate question with similar triangles built in. So our question says a spotlight is on the ground 20 feet away from a wall. A 6-foot tall man is walking towards the wall at a rate of 2.5 feet per second. So I'm going to draw that out to start. So this is my triangle. I have a guy who is 6 feet tall. And I have a spotlight that is 20 feet away. That spotlight is on the ground here, and it's shining up in that direction. This man is walking this way at a rate of 2.5 feet per second. So now I need to start labeling things. For now, I'm going to call the distance between the man and the wall x. So the speed that he's going, dx by dt, would be equal to 2.5 feet per second. Since the distance that he's moving is decreasing, we have to make sure that we make that a negative value. So it's going to be negative 2.5 feet per second. The next part of the question says, how fast is the length of his shadow on the building decreasing when he is 8 feet from the wall? So I'm going to call my shadow length y. dy over dt is our unknown in this case. This is what we're solving for. It also tells us that we're looking for it at an instantaneous time when the man is 8 feet from the wall. So that means for our instantaneous time, x is going to be equal to 8. So I can solve this up using similar triangles. The first thing we compare is our height. And the second thing we compare is our length. So for our height, we have y over 6, so the length of the shadow compared to the man's height. And for our x values, or our length, we have 20, which is our larger one, over this here. And I don't know that right now. I know that the big length is 20, my small length is x. So in order to do that, I have to write 20 subtract x for this unknown region. So this is how I set up my similar triangles. From here, we can start solving. So I'm going to cross multiply. So I have y times 20 subtract x equals 120. Now I want to get my y by itself. I don't really like that there's two derivatives here. I don't want to deal with it. So I'm going to divide both sides by this just so I have 20 minus x on the other way. There is more ways you can do it. You can do a product rule for this if you like that. I don't want to deal with that right now because I don't like doing product rule for stuff like this when there's more than one variable. So I'm going to move it over here and I'm going to say, okay, that's the exact same thing as if I brought what's on the bottom on the top and made my exponent negative. So now I'm going to take my derivative. So I'm going to do dy by dx. I don't have to do anything with this 120 because it's a constant, so it's just going to be hanging around the whole time. But I am going to take the derivative of this. Notice that I have a number in my exponent that isn't 1, which means that I'm going to need to do a chain rule. So I bring what's in my exponent down, which is negative 1. And then I need to change my exponent to be negative 2, so I'm subtracting 1 there. Now I need to multiply by the derivative of the inside. The derivative of 20 is 0, and the derivative of negative x is just negative 1. But I'm taking the derivative of x, so I need to write my dx over dt. So now when I get here, I can simplify it a little bit more. Negative 1 times negative 1 is going to make positive 1, so I'm not going to worry about it right now. And I can start filling in the values that I know. So I have dy by that should be a dt, I take it with respect to time, is equal to 120 times 20 subtract 8 to the power of negative 2. So I know that my x value is 8 for this instantaneous time. And my dx over dt value is negative 2.5. So as I keep going, I'm going to do dy over dt equals 120 over 12 to the power of 2. 20 subtract 8 is 12 to the power of 2 times negative 2.5. And if you plug this into our calculator, we'll get negative 2.08 feet per second. So double checking to make sure that negative makes sense. As he's moving towards the wall this way, the shadow on the wall is decreasing. So if something decreases, I need to have a negative number as my solution.